Thank you for joining us today on the Game of Stones podcast. Today we're going to do a little bit of a segment on some subject matter that involves setting up your shop, some of the main things that we need to set up like electricity, water, air. My name is Joe Alva, CEO of Poseidon Industries, founders and creators of the T-Rex 5-axis hybrid center, which executes the hybrid cycle, the world's fastest process for fabricating stone countertops. What I'd like to get into today is talk a little bit about a subject that we don't really pay too much attention to, in my opinion, which is water filtration and water reclamation. Okay, water supply to the different types of tools and equipment and processes that involve making a countertop. So what makes a countertop, right? Currently, the traditional system is cutting on bridge saws, cutting on CNC saws, or cutting on saw jets. Well, a CNC saw jet, or CNC bridge saw, regular manual saw, they take about 5 to 6, maybe 7 gallons a minute of water per machine, plus or minus 5%. And that's not a lot of water capacity per machine. But there is a lot of water consumption when you're talking about edge machines. You have mainly two types of edge machines. You have backsplash polishers that require 25 to 30 gallons a minute. So you're talking about 5 to 6 times more than a bridge saw. And then you have bullnose machines, or standard edge polishers. And these machines will do full bullnose, half bull, bevel, quarter round, demi bull, what have you, flat polish. But these machines, since they have so many more heads on them, they have chamfering heads, they have usually more heads on the bridge, plus you got the diamond, then you got chamfers if you're doing 2cm plus 2cm lamination, like some markets like Miami or California, or a little bit in Salt Lake, a little bit in Arizona. You're gonna have to kill the corners before you do a full bullnose, if you're doing full bullnose. Now, a lot of people haven't seen full bullnose in probably the last 10 or 15 years, but they say it could be coming back. I don't know. But anyway, those standard edge polishers, or what we call bullnose multi-head inline machines, those bullnose machines usually take between 40 to 55 gallons per minute, which is a lot of water. Okay, then you got CNC routers. CNC routers are going to take usually a clean water line through the center spindle line, so that absorbs the heat generated by the spindle as it's pushing the tool, so it helps cool the spindle. That water typically should be city water, super clean water, unfiltered water, unrecycled water. There's also the halo refrigeration tool part, which is about 8 gallons a minute. Those 8 gallons per minute, some machines take 6, some machines take 7, but roughly, let's say 8 gallons a minute, that water can be recycled, okay? There's a certain low micron number. But what we don't talk about is, we only talk about gallons per minute when you're calculating a water reclamation system or a water filtration system for the whole shop. And why does it have to be one system for the whole shop? And then you got hand tools and hand polisher guys that do touch-up polishing. They probably take about 1.5 gallons per air polisher. And so if you have 4 or 5 people doing touch-up, then you're looking at only about 5 to 8 gallons per minute on the hand polishing side. You got the edge machines, you got the bullnose machine, you got the backsplash machine. And on this side, you maybe have 2 CNC saws, and I'm talking about a large, higher production shop that may have 2 or 3 routers, and you have 3 routers, and you have 2 saws. Well, if I count the water that I need on 3 routers, you're looking at 8 gallons a minute. That's about 24. And if I look at 6 gallons a minute on 2 saws, you're looking at 12 gallons. 12 plus 24, we're talking 36 gallons per minute on this side for 5 machines. Over here on this side, I got a backsplash machine that's 30 gallons a minute, a bullnose machine that's 50 gallons a minute. Then I got random water for, air polishers, manual air polishing machines, and you got about 100 gallons a minute on this side. Okay. So my opinion on this, because I just feel like this is the most logical path to take, Let's talk about sludge concentration per application. So sludge concentration means how much sludge is in the water that's coming off of the saw. So these two saws have 6 gallons per minute. Well, what's the water quality like coming off of that saw? Well, that blade is cutting 1/8 of an inch by 1.25 inches thick for the whole length of the slab with only 6 gallons a minute. So there's a tremendous amount of sludge being generated because the blade is not just cutting the stone, but it's cutting into the concrete, and it's also cutting, it's the tool wear, right? And so you have a very dirty kind of water because it's only 6 gallons a minute, but it's generating a lot of sludge constantly. If you had to calculate the percentage of sludge in the water volume that's coming off of that saw, you're probably at 30–40% of it is sludge, right? There's a lot of sludge. The saw is definitely the dirtiest machine. It's also one of the lowest water volume machines. Then you got the CNC router. Well, the CNC router, it's not as dirty as the saw. It's a little dirty because the finger bit, if you're using the finger bit to open the holes, which a lot of people don't because they're using a water jet to open the holes, but if you're using the finger bit to open the hole, we'll go with that example, the finger bit is cutting very low linear footage of finger bitting, right? It's only doing maybe a vanity or a kitchen sink per one slab. So you're talking about roughly about 8 or 9 linear feet on the sink, on the kitchen sink, and maybe 4 or 5 linear feet on the vanity. So you're doing a very small volume of sludge because the finger bit is 3/4 of an inch thick going through 1.25 inch material. However, after that, there's a Super Z that cleans up the sink, cleans up the outside edges on all the countertop pieces that are on the router, and then you have position 1 through 6 that are taking literally, the Super Z is taking 1 millimeter off, which is about a 30-second, and then you have position 1 through 6, which is taking less than a 30-second off every single tool, 6 positions, with a lot of water coming down 8 gallons a minute per pass. So if you have 7 tools after the finger bit, then you're having 7 tools that you're really taking off a millimeter or less by 8 gallons a minute that are falling down on the machine. So the total sludge concentration in that whole process compared to a saw, instead of being 40% of the water is sludge, you're probably looking at something around 15% as a ratio of sludge to water concentration, okay? Now we got those machines set aside, let's talk about the backsplash machine and the bullnose machine. Well, the backsplash machine is polishing with abrasives, and mostly, let's face it, today's market, everybody's doing flat polish. So you're basically just doing flat polish on the backsplash, or always anyway, by the nature of the machine, it only does flat polish. So you'll do 6 heads, and you have a couple chamfers that might kill the corners on the corners for the flat polish, but those 6 heads are polishing, and they're taking literally micromillimeters off the face every time they're spinning with a lot of water. You got 30 gallons a minute, but all those abrasives, all they're doing is taking little microgranules off the face of the stone when they're polishing. So you're talking about a sludge concentration of 3 or 4 or 5% for all that major volume of water. In other words, these machines produce very clean water when they come off the polishing. Same thing with a bullnose machine. A bullnose machine, it's doing very little. Even if it's rounding a corner, the diamond only rounds off the corner of the material. After that, you got 1, 2, 3, 6, 7, 8 heads that are polishing the quarter round on the stone. Once again, it's taking micromillimeters off the surface with a lot of water falling down on the machine. Once again, you're at 5% sludge concentration. It's even less for the hand polishing guys because they got water coming in, and same principle, they're only taking off micromillimeters off the face of the stone. So the edge machines and the hand polishing are creating clean water, very clean water when compared to a CNC router, and definitely way cleaner when compared to a saw. Yet, many people are making a one-stop system with a high volume of recycling capacity to force the high volume machinery, which creates very easily filterable water because it's a very low sludge concentration. So we're mixing in a small quantity of high sludge producing machinery equipment to filter that dirty water to force it to be able to be used for machines that actually produce low sludge concentration water. These edge machines here, even though the water might look filtered and clean, on an ionic level, when you take dirty water and you filter it through a big recycling system, that water, it's getting maximized in its saturation of small particles and ions. On an ionic level, it's almost like ocean water, salt water. That salt water looks clear, but if you try to drink it, it's not going to be very tasty. It's going to be filled with salt. The other thing is that its refrigerating or cooling properties are vastly diminished because it's so super saturated that even though the water looks clear, its cooling effect is at a fifth of what it could be if it was less filtered and less dirty when it goes through a filtration process. So what's happening is that on your edge machines and on your hand polishers, even if the water looks clear and you're filtering all of this water on a one-stop shop system, you're gonna end up wearing out bearings, seals, abrasives much faster by using this highly ionic saturated filtered water. And there's really no reason to do so. You're better off getting one system for the dirty machines that create a high concentration of sludge, and getting a very simple system to just recycle the water coming off of the edge machines and the hand polishing tools. Okay? Why? Because they produce clean water with very low sludge concentration. So if you built perimeters around the edge machines and around your area, or you do a grading trench drain around your polishing area, and you had a sump hole that just has sump pumps wherever these machines are inside of this enclosed perimeter. It can be a trench drain or it can be a moat or a curb. Under the edge machines, it's easy to do a curb because the water all pretty much stays just overflowing from the chassis of the machine where the belt is. And it's very easy for the water to fall to the ground and encapsulate it with a little moat that is out of the way of the operator so nobody can trip. And it's very cheap to do so with bricks or a curb if you'd like. And inside of that perimeter, you make a sump hole. A 30 inch by 30 inch by 30 inch with a sump pump is fine. And these sump pumps can take the water to a large cylindrical plastic holding tank. You can have another one next to it, and you can put tubes connecting them so that they naturally decant into the other, and the sludge can settle at the bottom of them, the very little sludge that you're going to have. And you can just pull water from the secondary tank and refeed and recycle the water. And really, you have a better quality water probably because it's not highly super saturated ionically, because it didn't have 40% of its volume of water that was sludge. It only always has 3 to 5% concentration of sludge because the process of polishing doesn't take that much granite off the face of the stone with all the clean water coming in. So this is a very inexpensive way to recycle your water on this side for the edge, for the tools that don't really create a lot of sludge. And you could build something very simple with pumps from Grainger, Home Depot, Lowe's. It's easily serviceable. You can do this all with the Schedule 40 PVC piping. And I recommend getting those more sophisticated systems in a smaller format for the machinery that actually makes sludge, which are saws and CNC routers. I hope that this was useful. If you guys have any questions or anything, you can get in touch with us at info@gameofstonespodcast.com.